children, welcome to Math Park. In our park, today we are going to learn about factorization of polynomials. Okay, and this is factorization of polynomials for grade 9 again. So in the series of polynomials. So before we learn factorization, it is very important to learn this algebraic identities. So this just you have to make the chart of all of these identities and put in front of your desk and please learn them. It is very important. Okay, let's start factorizing. Let's take up the first question. When we look at this first question, we see that the first number and the last number here is a perfect cube. So this must be in the form of a cube minus b cube, or a minus b the whole cube. So we have an identity here, that is a minus b the whole cube is a cube minus b cube minus 3a square b, or x cube minus y cube is minus 3x square y plus 3xy square. So this is what we did. We just established this question in the form of identity. Comparing this, now 27 is the cube of 3. So this is 3 and y cube root of y is y. So 3y the whole cube, instead of this we wrote. Then 3x square y minus 3x square y. So your x here, remember, is now 3y. And your y here is 1. That you need to understand. Which are the perfect cube? Your y is 1 here. And compare with this identity and look at this, what happens. So minus 3x square y. So minus 3 in bracket 3y the whole square into y, which is 1, plus 3xy square. So what is your x here? 3y. 3 into 3y into y square and minus y cube, which is 1 cube. So what you see here, this is in the form of x cube minus y cube minus 3x square y plus 3xy square, which is nothing but x minus y the whole cube. So this identity is in the form of x minus y the whole cube, which can be written as x minus y thrice, that is 3y minus 1 into 3y minus 1 into 3y minus 1, and these are the factors of given cubic polynomial. Okay, now the next question here is 2x square plus y square plus 8z square minus 2 root 2xy plus 4 root 2yz minus 8xz. Now look at this identity. X plus y plus z the whole square is x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Now here this term is negative. Of 2xy, here you have negative 2 root 2xy. So either of your x or y could be negative. Okay. Then again look at the last term. It is minus 8xz. So either of x or z could be negative. Since both the places you have x and x here, so definitely your x term, this has to be negative. So this is your first term. So that means this 2x square is nothing but it is the square of minus root 2x the whole square. Clear? This y is y square again, and 8 is square of 2 root 2 z the whole square. So what we have done now, we have established in the form of x square plus y square plus z square. So these three we have got now when we compare this. Now we have 2xy. Now you understood now what is your x. X is your minus root 2x. Let us write whether we get in this form or no. So we write here plus, because comparing with the identity, plus 2. In place of x, I'm going to write this one, which is minus root 2x. And in place of y, of course, y. Okay. Plus 2yz. So again, 2y is y itself, and your z is 2 root 2z. So it is 2 root 2z. This is z, okay? And now this we have done, this part done. Now plus 2zx. So plus 2z. Z is again what? Your z is 2 root 2z, okay? And your x is again minus root 2x. So this is multiplied, so we write minus root 2x. So check whether we are getting in the same thing or what. Are we getting the same expansion, or have we written the correct expansion of whatever was the polynomial given here? So let's check it. Let us verify that. So here we see 2 into minus root 2x. This is going to be minus 2 root 2 xy, which is the same as here. Again, 2 multiplied by 2 is 4, and 4 root 2 yz. So yes, this is in the form of 4 root 2 yz, correct. and this is 2 2s are 4, and root 2 into root 2 is 2. So 4 into 2 is 8. So yes, this is, and plus into minus is minus. So this is minus 8xl, right? So we got this in the form of, this is the expansion of what? This is the expansion of x plus y plus z the whole square. So what is your x? It is minus root 2x plus y plus 2 root 2z the whole square. Okay. Now, if you don't want to write this negative, this can be shifted over here. So we can also write this as y minus root 2x plus 2 root 2z the whole square. And the factors are, since it is square, we can write the factors as y minus root 2x plus 2 root 2z multiplied by y minus root 2x plus 2 root 2z. Got it? So just you have to compare with the identities. That's it, children. Okay, let's move on to the next question. So 40x cube minus 135. When we look at this, both the numbers, we don't find they are the perfect cube. So how can we have the perfect cube? So what can be taken out common so that I get the perfect cube? Yes. If I take 5 common, I'm getting 8. 5 8s are 40, and 27 into 5 is 135. So 2, this 8x, 8 is the cube of 2. So this we are getting in the form of 5. This is 2x the whole cube minus 27 is the cube of 3. So 3 cube, correct? Now we have got this in the form of a cube minus b cube. So we have an identity a cube minus b cube, or x cube minus y cube. I don't know why I always have the habit of saying x. A. So any which ways, both are same. Some books write a cube minus b cube. Some books write x cube minus y cube. Also, x cube minus y cube is equal to x minus y into x square plus xy plus y square. So let us write this in the form of x minus y. Your x is 2x. Your y is 3. So 2x minus 3 in bracket x square, which is 2x the whole square, plus xy, that means 2x into 3, plus y square, which is 3 square. Let us expand this. 2x the whole square, we get it as 4x square. 2 into 3 is 6x, and 3 square is 9. And these are the factors of 40x cube minus 135. Got it? So just see that how can we bring it in the form of identity. That's important. Got it, children? Factorize 2y plus x the whole square multiplied by y minus 2x plus 2x plus y the whole square into 2x minus y. Now, when we compare this, you can see that these two things are here same. You have 2x here, you have 2x here, you have y here and y here. But this is y minus 2x, whereas this is 2x minus y. If I have to make it y minus 2x, then I'll have to multiply by minus 1 over here. So by multiplying by minus 1, this becomes y minus 2x. Now here we have y minus 2x and y minus 2x common, which can be taken as common. So y minus 2x taken common from here, 2y plus x remains, 2y plus x the whole square remains, and from here 2x plus y the whole square remains. Now this we get in the form of x square minus y square. So we have an identity x square minus y square is x minus y into x plus y. Let us write in that form. So y minus 2x was there. This is your x and this is your y. This entire thing is your x. Compare with this identity. So 2y plus x plus 2x plus y. This is what? A plus b, or x plus y. And then x minus y. 2y plus x minus 2x plus y. So when we are expanding this further, we get 2y plus 3y y as 3y, and x plus 2x is 3x, and 2y minus y, this is going to be minus here, 2y minus y is y, and x minus 2x is minus x. This is how y minus x we got. Again, from these we can take 3 common. Taken 3 common, x plus y remains. So the factors are y minus 2x into 3 into x plus y into y minus x, where we can write this 3 numerical thing first. So we have here 4 factors: x, 3 multiplied by y minus 2x multiplied by y plus x multiplied by y minus x. Got it? Okay, let's take by factor theorem. Okay, this is also easy. This can be done even by splitting the middle term, but we are going to learn by factor theorem how do we factorize. So if we take this polynomial as p of y is equal to y square minus 5y plus 6, then the factors of py are y minus a and y minus b. where A, B are the factors of 6. So let us take the factors of 6. We know that the factors of 6 are 1, 2, and 3. Factors are the numbers which are the complete divisors. That means if I divide 6 by 1, I'm going to get remainder 0. If I divide 6 by 2, I'm going to get remainder 0. If I divide 6 by 3, I'm going to get remainder 0. So when we divide this, we now substitute by factor theorem. What we understand that if I'm going to substitute p of 2, I should get 0. So when I'm putting p of 2 here, 2 square is 4, 5 multiplied by 2 is 10, and plus 6. So that is how 6 plus 4, 10, 10 minus 10 is 0. So this is how we get y minus 2, because 2 is the 0 of this polynomial. Okay, so that is why y minus 2 is the factor of p of y. Now let us take p of 3. So we substitute here, 3 square is 9, 5 multiplied by 3 is 15, and plus 6. 9 plus 6 is 15, and 15 minus 15 is 0. So y minus 3 is also the factor of p of y. So what we understand then? So since it is a quadratic polynomial, with the quadratic polynomial is the polynomial of degree 2, which will have 2 zeros only. So this is how the factors are: y minus 2 multiplied by y minus 3. Got it? The same can be even done by splitting the middle term, which we have already seen in previous videos. Let's move on by factor theorem. One more question. Now here I cannot see any identity. I can't take common. I don't have, though I have x cube here, I don't have the one more cube term. So in this case, we'll be using the factor theorem. So for factor theorem, we'll be finding the factors of the constant. So factors of 60 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 5, plus or minus 6, plus or minus 10, plus or minus 12, plus or minus 15, plus or minus 20, plus or minus 30, and these are all the factors. Now, by factor theorem, by trial and error method, this is by trial, we'll just check on. Okay, we'll just check on. So we put p of 3, put it in the this polynomial. In place of x, we are putting the value of 3. So 3 cube is 27. 3 square is 9. 12 into 9 is 108. 47 multiplied by 3 is 141, and minus 60. When I add this, I'm getting 168 minus 168, which is 0. Okay, just two negatives added, minus 108 minus 60 is minus 168, and 27 plus 141 is again positive 168. This is how we get 0. So we understand that x minus 3 is definitely a factor of this given polynomial. Okay, because p of 3 is equal to 0. Now let us take p of 4. Okay, we are just choosing. So luckily, you after practice, you will understand which one to hit for. We cannot keep on trying for all of these factors. Okay, just try for which one you will be able to, like 3 we tried with, now we are trying with 4. Okay, now we put here 4 cube. 4 cube is 64. 4 square is 16. 16 into 12 is 192. 47 into 4 is 188. And when we add it, we are getting 0. So yes. So what we understand that x minus 4 is also the factor. Like here, x minus 3 is the factor. Let's try with p of 5. So 5 cube is 125. 5 square is 25. 25 into 12 is 300. And 47 into 5 is 235. Minus 60, we get this as 0. So we get here that x minus 5 is also the factor. So this is how by factor theorem, we get x minus 3, x minus 4, and x minus 5 are the factors of p of x. Thus, x square minus 12x square plus 47x minus 60 is nothing but the product of x minus 3, x minus 4, and x minus 5. Got it? With the help of factor theorem, what we understand there? The remainder has to be 0. Okay. If x plus 1 upon x is equal to 6, find x square plus 1 upon x the whole square. So what do we do here? We square both sides. Square both sides of this. So x plus 1 upon x the whole square is equal to 6 square. Okay. We have the identity x plus y the whole square is equal to x square plus y square plus 2xy. Same thing we are going to do over here. So your x is this, so you get x square plus y is 1 by x, so 1 upon x square plus 2xy, that is 2 into 1 into x into 1 upon x. So this and is equal to 36. This x and x got cancelled. So you get x square plus 1 upon x square is equal to 36. This 2 goes here, it becomes minus 2, which is equal to 34. Now, if you have to find x to the power 4 plus y to the power 4, again, you will be squaring this. It's easy, children, and very important questions in the examination. If you like the video, please share with your friends. Thank you for watching. Have a good day.